I'll just give the presentation another 30 seconds, allow other people to join, and then I'll get started. Right, I'll get started and the others can sort of join as the presentation goes on. Thanks very much for attending. My name is Chris Mandall. I'm the National Render Manager at Seeker. That means I typically look after all things basement refurb. So hopefully we'll be able to provide you with a bit of insight into basement refurb waterproofing. So just a bit of an overview in terms of the sort of housekeeping for the webinar, really. Everyone's microphones and cameras are turned off. So if you could please put any questions into the chat, we will do a Q&A at the end of the presentation to save sort of ongoing answering of the questions throughout, just in case there are sort of a large amount of questions. But we will do a Q&A at the end, so feel free to put them in the chat and we'll pick them up later on in the presentation. And everyone will receive the slides after the recording session, so you will be able to go back over some things that you may have missed if I do brush over it a little bit too quickly. So yeah, they will be sent out following on from the presentation. So just a bit of a agenda for what the CPD is going to include. It's a bit of an introduction to Seeker, who we are as a company, for those of you who aren't aware already. Then on to BS 8102 2022, so the Code of Practice for Protection of Structures Against Water from the Ground, and why it's important. We'll touch base on some of the types of waterproofing that can be used for basements, i.e. multi-coat render systems, other type A cementitious products that can be used, along with cavity drain systems. I will do a sort of a brief overview of type B waterproof concrete products, because they are used on some basement refurbs, but it will only be a brief overview on that. Combiflex and jointing, which is effectively the movement joint and construction joint product used in conjunction with some of these basement waterproofing products, and then over some typical details and sort of why we waterproof some areas and how those are detailed. So, overview of Seeker and who we are. For those of you who aren't aware of who we are already, we're a provider of construction materials. We cover a wide range of different sectors within construction. We have over 1,000 employees in the UK. It says 5 sites on there. It's actually now 6 sites after the acquisition of MBCC. So we've also got Redditch, along with Welwyn Garden City, Preston, Leeds, Dublin, and Wishaw. So very large, been growing over the last sort of 40 years significantly, especially with a lot of the acquisitions that have happened. Some of them you can see at the bottom of the screen there, which has allowed us to grow to a company with a turnover of 360 million in the UK. So incredibly large in terms of the business and the construction materials that we supply. I mentioned we provide construction materials, and that's across loads of different sectors, not just waterproofing. So as you can see here, 8 different sectors. Concrete, so that's the admixtures, fibers that go into concrete within a lot of structures. Waterproofing, what we're going to be covering. Roofing, building finishing, floorings and coatings, sealing and bonding, engineered refurbishment, and industry. There is a lot of crossover through the departments. Basements that have waterproofing may also have roofs, and there's opportunities for sealing and bonding and different types of flooring and coatings that may be required on those also. So if you are working on a project that has basement waterproofing, we may be able to assist in the other departments as well, as we provide sort of a full range of construction solutions. So that's a brief overview in terms of who we are. We'll now go on to sort of the waterproofing side of things and what we provide as a business in terms of application areas. As I said, it's extensive. We provide a wide range of products for basement waterproofing. That's new build and refurbishment, although we will be just covering the new build aspect today. Podium deck waterproofing, again, something that's seen on a lot of new build projects, but we do also see podium waterproofing on a lot of the basement refurbs that we're working on. So there may be a sort of an overlap and maintaining continuity between internal waterproofing and that podium deck waterproofing that may be on the project you're working on. Bridge deck waterproofing, tunneling, Swimming pool waterproofing, again, something that occurs in basement refurbs in a lot of instances. Waterproofing retaining walls, water industry, pit and pond waterproofing, and containment linings. So as you can see, we cover a wide range of waterproofing scenarios. So we have a wide range of products that matches up with that very well. So on to the industry standards. As mentioned earlier, BS 8102 2022, the Code of Practice for Protection of Structures Against Water from the Ground. Really, it's the industry Bible when determining the level of waterproofing that's required for a structure. So it addresses recent industry developments, more deep construction in urban areas, how that will affect the surrounding areas, surrounding basements, increase in residential basements, especially over the last sort of 5 to 10 years. And in areas like London, where space is so important, a lot more basements are being built and a lot more deep basements are being built. Development and use of new waterproofing materials. Waterproofing is always evolving. There's always new products coming to the market and different areas in which they can sort of slot into the market and applications they can be used for. So it does cover different and new forms of waterproofing. Covers the publication of Eurocodes, and then it covers the 3 different types of waterproofing, types A, B, and C, and the 3 grades of basement 1, 2, and 3. So we will go into a bit more detail in terms of some of those points BS 8102 covers very shortly. So it was revised in March 2022. The previous document was BS 8102 2009, so last updated sort of 13 years before that. So there are a few different changes that you may not be aware of that are within the latest adaptation of the British standard that weren't necessarily in the previous standard. One of those being the further information on basement refurb. 2009, it was a massive grey area. There wasn't really any guidance in terms of what needed to be done for basement waterproofing. That has changed now, and there's a bit more information in terms of how that is reviewed and how the level of waterproofing is addressed. So it addresses developments relevant to specifying, designing, constructing below ground structures. It covers water ingress from all sources, including floodwater, failed services, as well as groundwater, pluvial and fluvial water sources. It advises that waterproofing specialists should be appointed as part of the design team. We will go on to this a little bit later on, but we'd always suggest that a waterproofing specialist is incorporated in the design team at the earliest possible design phase. Whether that's an independent design specialist or whether that's a manufacturer like ourselves that have people that are certified surveyor in structural waterproofing and can provide that early design guidance. A comprehensive refurbishment section, as mentioned, section 6 has now been added, which covers what to do when you're waterproofing a basement refurb. It notes that contractors have an obligation to manage risk and develop a water management plan. Something that's key, really. Obviously, value engineering is something that happens a lot in construction. Previously, it had happened at the expense of the robustness of the waterproofing design in a lot of instances. With that being included within the standard now, it gives the contractor more responsibility to make sure that the design is as robust as it can be from the earliest instance. And it highlights that successful waterproofing strategy is devised as a team, all parties communicating effectively. I think this is a key point, really. If the design is done at a late stage of a project, sometimes it can be shoehorned into the drawings that an architect or an engineer had provided, and it may not be the most robust strategy for that particular scheme. But if we're all working as a team as early as possible, it gives us a better chance of providing a robust strategy that works hand in hand with the design the architect's providing, opposed to us trying to shoehorn in a design sort of later down the line. So if all parties are communicating and involved at that earliest possible phase, it eliminates a lot of the risk that could potentially be involved in designing waterproofing. So the Figure 1 design flowchart, it outlines the principal factors and stages to produce a robust waterproofing solution for a below ground structure. So the design team structure, so who's incorporated within that design team and who has an influence in the waterproofing for that particular project. The risk assessment, so identifying the risk that's associated with the site, water table, are there any ground gases, the topography of the site, give us an indication in terms of whether there's going to be any water pressure bearing on that structure. Water table classification, and then the client requirements and intended use. So whether the client is requiring a completely dry dry basement, and whether the intended use means that it needs to be completely dry, or if there is some damp and seepage going to be necessary and obviously accepted within that space. So BS 8102 2022 includes reference to the design life of the structure, something that is key. Obviously, waterproofing is there to be designed for the design life of the structure. Continuity, make sure in that waterproofing continuity is maintained. If there are any breaks in waterproofing, it obviously could be a high risk area and water finds the path of least resistance. So if that continuity isn't maintained, it's likely you're going to have an issue with water ingress. Installation. Installation in a lot of instances can be a point of failure with waterproofing. The design is key, the products are key, but also finding a person to install the waterproofing that is competent is also going to be key to eliminate any potential failures in waterproofing. And then commissioning and maintenance of systems. So within the three different types of waterproofing, type C, your cavity drain system is a maintainable system, so needs constant maintenance to obviously comply with British standards and obviously work and remain working. So that's also included within BS 8102. So the design team, firstly a geotechnical specialist. This is something that's appointed on mainly new build projects. It's not something we necessarily see on refurb projects in a lot of instances. On a new build project, you've got your boreholes to identify the type of ground, where the water table sits, so the hydrology, external drainage, groundwater conditions. This will give you an understanding of the risk that's associated with the site, and this will give us a bit of an indication before we start putting our design together in terms of how high risk the site is and what level of waterproofing needs to be provided for that particular project. It's then the waterproofing specialist, so appointed as part of a design team to ensure an integrated waterproofing solution. That integrated waterproofing solution is key, making sure that's sort of put together at the as earliest possible instance to make sure that the waterproofing design is robust as possible. So as mentioned, that could be a manufacturer like ourselves or an independent design specialist. Typically the difference between the two, just to sort of elaborate on that, obviously waterproofing specialists independently will be appointed as part of the design team, which typically means there's a fee associated with doing so. They'll be incorporated in that design team. They'll then cover that waterproofing design under their PI. I know a lot of projects nowadays require 10 million PI, which they'll be able to provide. They'll then provide a suite of project-specific details associated with that particular project that will be covered under their PI. Where that differs from a manufacturer like ourselves is that we hold PI against our own design input and our products that we supply for the project if incorporated within that design, but that's specifically for our products and our service, opposed to a rounded waterproofing the design that covers the entire scheme. So yeah, our design will effectively incorporate our products, and if they're substituted out, you could potentially risk compromising that design. We will still happily be incorporated as a design specialist to provide project-specific details for that scheme. So the risk assessment, as mentioned, a lot of the time this is typically done for new builds, not necessarily for refurb projects, but something to be aware of anyway, because there are certain things within this, like groundwater, topography of the site, land drains, that will be key on refurb projects, although the investigation may not necessarily be done. So water table, static, variable and perched. So static, the water table currently sits either above or below the underside of the slab throughout the course of the year. So if it's above the underside of the slab, you've got a high water table, it's a high risk site, therefore you may need to pay extra attention to the waterproofing, i.e. incorporating additional layers of protection. Variable is where the water table fluctuates. So during the wetter months of the year, it could be above the underside of the slab. Dry months of the year, it could be below the underside of the slab. Where you have that temporary hydrostatic pressure bearing on the structure, again, special care needs to be paid to the waterproofing as that structure is under water pressure. Perched is where you have less permeable soils. So, for example, you've got a band of clay, which is a less permeable soil. As water is percolating down through the soil, it will hit that band of clay and you'll have temporary hydrostatic pressure. So on new builds, you'll try to alleviate that pressure as much as possible by having external land drainage, which can sort of temporarily reduce the water pressure that's bearing on the structure. With refurbishment projects, that's not necessarily the case. You can't sort of excavate on the back of that retaining water, incorporate land drainage if it isn't already there. So we've got to accept that the perched water table is there and deal with it within the waterproofing design accordingly. So water from sources, water mains and sewers, and then the effects of climate change. Is climate change going to have an effect on the water table for that particular area? Ground drainage, as mentioned, the topography of the site. So the site at the top of a hill is going to be drier than a site at the bottom of the hill. Land drains, effects from neighbouring structures. So our neighbouring structures and whether they have a basement, whether there's work going on to that property next door, is that going to cause an effect on your basement later down the line or currently? And then ground conditions. Typically gases. So what's the characteristic situation for that particular site? Is there a requirement for gas proofing? Again, something that typically happens with new builds, not necessarily with basement refurb, but you never know, that could be a consideration on a lot of projects going forward. All of the above can have an impact on the waterproofing for that particular project. So they're all things we need to be aware of at the earliest possible design phase. So client requirements, obviously a key one to get an understanding of what the client's requirement for that basement is. One being what the space is going to be used for, the intended use of the space. And secondly is how dry they require that basement to be. So when it comes to basement refurb, obviously you're relying a lot on the existing waterproofing, and you can see the existing condition of the basement, whether it's dry currently, whether there's some damp patches currently, whether there's seepage. The current condition of the basement will give you an indication in terms of whether that's going to be acceptable going forward for the client, or whether that doesn't meet the expected performance levels based on the change of use that may be happening within that area. So does the client understand the difference between wet, damp and dry? Although that sounds quite clear, wet, damp and dry, there are key factors, especially with the damp side of things, whether the damp is caused by internal factors or external factors, which may mean that the basement may be classified as a different grade and therefore may need extra attention when it comes to the waterproofing. Have the cost associated with achieving the dry basement been considered? I think this is a key point as well. And another point as to why incorporating that waterproofing specialist at the earliest possible design phase is key, because we see in instances basements being designed based on the lowest level of protection, where that lowest level of protection may not actually meet the client's requirements in terms of the grade of basement they're hoping to achieve and the performance level for that basement. So if we're incorporating that design specialist at the earliest possible design phase, they'll give you an indication in terms of what's required from a waterproofing point of view to comply, and then you can start to understand whether there's a budget to achieve that and what can be done to obviously help achieve that level of waterproofing, rather than compromising the waterproofing to achieve the budget. Has future use of the building been discussed? Again, a key point. You always look to future proof. Is there going to be a change of use in the basement 10 years, 20 years down the line? And has that been accounted for when it comes to the waterproofing? You may be designing the basement currently to be relatively dry but have damp patches, but there may be plans in 10 years to generate a habitable space out of the area that's currently been designed for damp patches. So it's understanding that future proofing and making sure that the design we implement now complies if it then does end up being a habitable space. It'll be a lot easier to do that in the first instance than try and retrospectively do it later down the line. And have the consequences of failure been discussed? Waterproofing is it's never completely without failures, whether it's down to workmanship or whether internal system gets punctured or something happens with the waterproofing that potentially causes it to fail. It's unavoidable in a lot of instances. Some instances it is avoidable, but it's always about making sure there is a plan in place so that if there is a failure, there's ways of remediating it. If there's no ways of remediating it, it's not going to comply, and ultimately it's going to cost you a hell of a lot of money to get fixed. So making sure there are sort of ways of remediating it incorporated in the design at that early stage means that it's going to be a lot more effective if things do go wrong. So consequences of failure. BS 8102 states that you must consider water is likely to bear on the structure. As mentioned, with the types of water table, it's very likely that water is going to bear on the structure at some time within that building lifetime. Defects must be expected. It's never completely foolproof. There are defects in a lot of instances, but it's about how you can repair and remediate those. The consequence of water ingress must be assessed, and the feasibility of repair should be considered. As mentioned, there always should be a plan in place for how that waterproofing is remediated should worst case scenario something go wrong. So we now go on to the grades of basement, so the different types of basement. Now, this has changed since BS 8102 was updated. There used to be 3 grades of basement, type grade 1, grade 2, and grade 3. There's now grade 1A, grade 1B, grade 2, and grade 3. So I'll briefly explain the differences between the different grades. Now, grade 1A, this is where there are seepage and damp patches acceptable within these areas. So if your client is designing it to be a basement car park and they're happy to accept the fact that seepage may come in and damp patches caused by both internal and external factors, if they're happy with that, then that space is going to be classified as a grade 1A. Although car parks and plant rooms are listed under grade 1A, it doesn't mean they are grade 1A. It's all about managing that client expectation in terms of the performance level that basement's going to meet. If that meets their performance level for a car park, then it can be classified as a grade 1A. Where that differs from grade 1B is that grade 1B has no seepage, so there's no physical water tracking into the basement, but damp patches are still tolerable. So as long as there's no actual physical water seepage, the basement will comply with a 1B. So this is still typically things such as car parks and plant rooms, excluding electrical equipment. Obviously, you don't want electrical equipment in a space that's likely to have a considerable amount of damp. Again, when it comes to a basement refurb, slightly different from new build, in that new build will typically have at least one form of waterproofing on every project. When you're working on a refurb project for an existing client and they have a basement car park that is currently, as it stands, with the existing waterproofing that is in place, even though you may not know what that is, it currently complies with a grade 1B, and the change of use of the basement is still classified as a 1B. It may be that they may not incorporate waterproofing within this space, as it currently, as it stands, complies with the performance level you're hoping to achieve. Now, that is perfectly acceptable, but the risk is there on the client. The space would be excluded from our design. There'd be no warranty for the space, obviously, as we wouldn't be providing a solution or a membrane for that particular location. So if anything does fail and water gets into the basement, there's seepage, and it no longer complies with a grade 1B, it would be at the client's risk. So although leaving some areas of the basement without any new waterproofing would be acceptable in that instance, it would be at the client's risk for that particular instance. We then move on to grade 2. So grade 2 is slightly different from grade 1B in that there's some damp patches, but they are caused by internal factors such as condensation or sort of internal air moisture. So there's no water coming through from external factors. That's the slight difference between 1B and 2. So these are typically your retail storage areas, plant rooms, workshops. They may include electrical equipment within these spaces. Now, we would typically recommend on a basement refurb that you would incorporate waterproofing within a grade 2. We have no understanding of what the existing waterproofing is. If the basement's dry now, it doesn't necessarily mean it's going to be dry in 6 months' time when the conditions and weather conditions externally get worse. By providing waterproofing to some areas of the basement could potentially lead to water finding a path of least resistance elsewhere. So when it's grade 2, we would always recommend that sort of waterproofing is incorporated, although that recommendation always isn't sort of taken up. Grade 2 waterproofing, you'll typically have one form of waterproofing incorporated within that refurb space, whether that's a type A cementitious multi-coat render system or a cavity drain system. With it being retail storage areas and plant rooms, typically you would go down the route of having a fully bonded type A membrane opposed to a water management system cavity drain system, purely on the basis that you'd incorporate maintenance, an internal blockwork wall, just to incorporate the cavity drain. It's better suited for a grade of basement that is still accepting of damp areas to have a membrane that can be left as the exposed finish. We then move on to grade 3. Now, these are your completely dry internal areas. There's no damp patches, there's no seepage, no water ingress whatsoever. Again, for basement refurb, not for new build, I must emphasize, basement refurb projects, you'll typically still only have one level of waterproofing for a grade 2 space. You'd always have one layer of new waterproofing for grade 3 basement spaces on a refurb. What separates grade 2 and grade 3? Obviously, if you've got a membrane or a cavity drain system, they both comply with grade 2 and grade 3. What separates them in terms of meeting that grade is that grade 3 basements have heating and ventilation incorporated. So the design from ourselves would still be exactly the same, but what makes it a grade 3 is the fact that it has heating and ventilation incorporated within that space. So there's a lot of things to obviously bear in mind when it comes to the grade of basement, which is why it's so key to make sure there's a plan in place in terms of what the grade of areas are at the earliest possible stage so that we can design accordingly and make sure it complies with British standards. We're then going to look at types of protection. So 3 different types of protection. Type A, which is your barrier protection. These are external or internal barriers. For basement refurb, we'll be looking at internal barriers, as you can't obviously apply a membrane to the outside of a retaining wall. But these are bonded sheet membranes, liquid applied, geotextile, which is effectively bentonite systems, mastic asphalt membranes, cementitious crystallization slurries and powders, and then cementitious multi-coat renders and coatings. So the last one there is what we're going to look at within basement waterproofing for refurb. Type B, which is your structurally integral protection. This is your waterproof concrete, so reinforced or pre-stressed concrete, and then concrete containing waterproof admixtures. It says steel there because designing the concrete to 0.2 technically counts as a waterproof barrier. Type B typically not used in a lot of basement refurb. As you can imagine, the structure is already there in a lot of instances. A scenario in which you may use it is if the retaining walls are being retained and there's a replacement basement slab. If you're restricted for space within your basement in terms of head height and you're replacing the slab, a way in which you could waterproof the slab opposed to having an internal system is to use an external membrane and then use waterproof concrete for your new basement slab. So there are basement refurbs in which type B systems are used. It's just not one of the primary methods unless elements of the structure are being replaced. And then type C, which is your drain protection, so your cavity drain membranes, effectively your ongoing maintenance system. Risk reduction, combined protection, again, more relevant to new build. You should always use combined protection on grade 3 basements on a new build project, not necessarily the case with refurb. So combined protection where necessary. Again, this would be a key point if you're replacing the basement slab. Obviously, you're removing the existing waterproofing is there. You can't necessarily rely on that going forward. So if you're replacing the basement slab and you have a grade 3 space internally, you would still need 2 forms of waterproofing because it's over a significant area. But other than that, one form of waterproofing along with heating and ventilation complies with British standards in grade 3s for refurbishment. So other considerations when designing waterproofing. Correct selection of systems is critical. Again, another reason to employ that design specialist at an early stage. Even though some systems on paper may look like they are suitable for a particular type of basement construction, there are things such as how easy they are to install, level of water pressure they can handle, that may not necessarily mean that they are the best system for that particular project. So consulting that specialist would make sure that the design is designed as robust as possible and all of the products that are used are the best for that particular type of application. Ease of installation is considered. Installation, again, as mentioned earlier, is a point of failure in a lot of instances for waterproofing. We know how things are on site. It's never always sort of foolproof in terms of the installation. Making sure the design is as simple on paper as possible makes it a lot easier to install on site. So you want to keep that detailing as simple as possible to eliminate any potential risks during the installation period. Again, making sure whoever's installing it, whether they're a specialist waterproofing contractor or just a normal contractor, has either had the relevant training or as competent as they can be to install that particular waterproof system. Ground level detailing is critical. One thing that's key for basement refurb, especially if you're retaining the entire structure, is that there's a break in continuity. You'll waterproof your basement, but then you'll have your intermediate slab and then your DPC 150 mil above external ground level. Now, if you're waterproofing your basement internally, you can't continue that waterproofing through that intermediate slab to terminate it at DPC. So there's a junction there where the continuity can't be maintained that we'll have to provide specific detailing for to make sure that the waterproofing is robust as possible. So key areas like that are things that we can focus on at that early stage to limit the risk. Use experienced and trained installers, as mentioned. That's key to make sure there's no installation issues. Remedial measures, make sure they're in place, make sure there's always a plan in case there are any failures within the waterproofing. Contamination, has it been accounted for that there may be ground gas and VOCs, and have we designed accordingly? And look at each project on its own merits. I think this is a key one. It's interesting for me, actually, because I see a lot of projects that are very, very similar on paper, and certain designs may have been used for that particular form of construction 5 years ago, and it's recycled, which isn't necessarily wrong. If it works, then keep recycling it. But each project may be slightly different. There may be new systems on the market. There may be better systems now that there were a few years ago that we may be able to sort of switch out for the systems that were designed then that can enhance the design and provide it an extra level of robustness. So always consult a specialist, take each project on its own merits, and allow us to design each project accordingly, rather than sort of recycling designs that may have worked in the past. And then podium decks are now included and should be later falls. Again, we can design podium decks. We have products for those. So if there are podium decks on the projects you're working on, please consult us again at that early stage. Apologies, my presentation has seemed to have frozen. Bear with me 2 seconds while I get this loaded back up. Here we go. We're on to Type C cavity membranes. As mentioned, one of the 3 forms of waterproofing identified within British standards. A lot of Type C membranes are used on new builds, but they are predominantly used on basement refurbs. Very, very robust system for working on a basement refurb, and they tailor themselves to sort of certain types of projects. So again, it may be suitable on one project, but may not necessarily be suitable on another. But in short, it's a water management system. Water is collected behind the membrane and then distributed via sumps and pumps within that basement. It's suitable for commercial and domestic projects. Not necessarily residential. A lot of basement residentials you're working on, especially if it's someone's living space within there, as the system needs to be maintainable, you may end up having rotting eye points within someone's living space, and therefore it's not necessarily ideal or that accessible. And it's suitable for new build and refurbishment. So give you an overview in terms of how the system works, based on the image on the left-hand side. You've got a 20 mil egg crate membrane on the slab, and an 8 mil membrane on the walls. They are then terminated at that wall floor junction, and they terminate into a channel, a perimeter channel. That perimeter channel collects the water, and then that will divert itself down to that sump pump, which will pump the water out of the basement. Effectively, you're allowing water into the structure and then managing it away. Now, as mentioned, they need to be maintainable, so you'd need a rodding eye point or access point for that perimeter channel every 10 to 12 linear meters and every change in direction. So it's about identifying where those access points are going to be at that early stage to make sure they are going to be accessible when they don't fall within someone's living space or fall within an area that's not easily accessible for repair if the cavity drain channel was to be blocked at any stage. They're very robust, as I say. Due to the fact that they are maintainable, they can be repaired relatively easy. And they manage that water away via the pumps. The pumps are required to be every 50 linear meters of channel. So if you've got more than 50 linear meters of that perimeter channel, you're more than likely going to need more than one pump. But that, again, that's something we can design from that early design stage to make sure that the number of pumps is suitable, but probably limited, and the locations of those pumps. The perimeter channel sits recessed into the slab. You can see at the wall floor junction there. This may be a difficult part with the basement refurb. If you've got an existing reinforced concrete slab the contractor may not be able to chase out that recess to incorporate that channel, which then means that the channel may have to sit on top of the slab. Now, because the membrane comes in over the top of the perimeter channel, if your channel sits on top of the slab, you're going to need to incorporate a sacrificial screed so that the membrane can then sit on top of it and drain directly into that perimeter channel. If you're restricted for head height in your basement, which a lot of basement refurbs potentially are, if you can't recess that channel in there, it may cause an issue for your head heights, because you'll have 50mm sacrificial screed, 20mm egg crate membrane, then you'll typically have your insulation and screed directly over the top of it. So you're potentially looking at 200mm plus of build up on top of your existing slab to incorporate a cavity drain system in that instance. So although it is incredibly robust and durable, where space is an issue, it may not be the most appropriate solution. Again, with the membrane on the walls, you've got an 8mm membrane on the walls that can't be left exposed. You'll typically have plasterboard in front of it or a cavity wall. So you're losing space on the perimeter of your basement to incorporate that channel as well. So it's a very robust system, very durable. It works perfectly fine on a lot of projects, but there are still some certain projects where it may not be suitable and another system may be more beneficial. So the sheets are fixed with plugs and joined with tapes. The perimeter channels discharged to a sump, and then the access points are for maintenance, as mentioned. This is a system we provide and can design from that early stage. So in terms of where those access points are going to be, that's something we can work directly alongside with yourselves to make sure they fall within areas that are going to be accessible. In terms of cost of the system and ongoing maintenance, the ongoing maintenance does come at a cost. There'll be maintenance costs for the pumps per year. Typically, I think it works out about £1,000 per pump per year. You're then going to need to replace the pumps every 3 to 5 years to maintain the manufacturer's warranty and the installation warranty, along with some of our side by side with one of our specialist contractors. Now, the ongoing costs of the maintenance are something that needs to be factored in from an early stage to make sure the client is aware of those, because it's not necessarily the upfront cost of the waterproofing, it's the waterproofing costs that are going to sort of occur over the next 10, 12, 15 years, however long that particular space is going to stay as it is. It may even be longer, dependent on the design life for that particular space. We then move on to type A systems, so multi-coat renders. Now, these are different from type C systems. They aim to allow water into the structure and then manage it away. These keep the water out. So effectively, they are a fully bonded membrane applied to the inside face of the wall that withstand hydrostatic pressure. So they're predominantly used for refurbishments, commonly specified on lift pits, basement refurbs, typically anywhere where there's a retaining wall. They're applied directly onto the retaining wall. They withstand that hydrostatic pressure and stop any water getting into the structure whatsoever. So there's no need for ongoing maintenance. This is a permanent solution and a barrier against all water ingress. In a high-risk environment where there's little or no structural works, it's a perfect solution. With it being fully bonded, any movement within the structure could potentially damage a fully bonded system. It could crack. So ultimately, you would apply it after your structure has been loaded, if there is going to be any additional loading, and after any sort of further structural works have sort of taken place to limit any potential failures of that system. They require minimal enabling works. A point I probably should have made with a cavity drain system is that they require intrusive work. So you're going to need to break out areas of that existing slab to incorporate a sump chamber. That's not required with a type A membrane. You have a 32mm thick screed on the slab and an 18mm thick 3-coat render on the walls. That is your permanent barrier. There's no need for any intrusive works. It's just a slurry applied to the inside face of the walls. Suitable where there's head height and internal restrictions, especially in London. A lot of these projects, we know space is so expensive and so important. So if you are limited for space, the reduced build-up of a render system internally may be beneficial. It's maintenance free, so ideal for residential projects, and it's popular on commercial and retail due to the reduced lifetime cost of the system. There's obviously not that ongoing maintenance cost that you'd have with a cavity drain system. I mentioned it's highly durable. It withstands 7 bar of water pressure, which is the equivalent of having 70 meters head of water bearing on the structure. So incredibly durable as a system. But there are limitations, as there are with every basement waterproofing product. They're rigid, again. So if there's any differential movement, high impact, there's the potential that that product could crack. Finishes directly onto it. If the finishes that are intended to be used are non-breathable, there's a potential issue with breaking the blocking the pores of the permeable surface of the render. So cementitious renders are breathable. They withstand hydrostatic pressure, but they allow moisture vapor through. The moisture vapor is negligible. It's not something that's going to be noticed internally. But if you put an impermeable surface on top of it, the vapor's got nowhere to go, and they could potentially appear as water ingress when really it's just trapped vapor. Seeker 1 add weight to the structure, so failure of the structure can occur if it can't support the new loadings. It needs to be installed onto structural substrate. So if there are existing finishes that can't be removed, if there's tiles that can't be removed, it's not going to be suitable to be applied. If the structure isn't strong enough, it's not going to be able to be applied to that as well, because again, when that structure is under the stress of the hydrostatic pressure, now that you've put a barrier in front of it, the structure itself could crack and potentially fail. Stopping leaks could build up that hydrostatic pressure, as mentioned. So you need to consult with a structural engineer from an early stage to make sure the structure itself can withstand that additional pressure that the render may actually cause on the structure itself. Curing is vital. Again, it's within all our technical data, it's within all our information that we provide, but curing is vital for making sure the system works as well as it possibly can. This is probably something you'd need to worry about at the point. It's something we can consult on at an early stage. But as mentioned, you're providing a barrier against water ingress, which then means that barrier is stopping hydrostatic pressure coming through and putting more strain on the structure itself. Now, this is just to make sure the slab doesn't go into uplift, which will cause a massive issue for the structural integrity, but also for the waterproofing. Now, if the head of the height of water is more than 2.5 times the depth of the slab, then the potential that the slab is in uplift. So that's something we'll look at from an early stage. And if that's the case, and that's the potential that could be the case, then the cavity drain system may be the better route, because that doesn't build up any hydrostatic pressure. It manages the water away. So examples of internal render systems are Seeker 1 pre-bag render system. It's a 3-coat multi-coat render applied to the inside face of the structure, withstands hydrostatic pressure. So each coat has its own different design ratio. The spritz coat that goes on first, effectively your bonding layer. You then have your render layer that goes on after that, and then your finishing mortar directly over the top. So your total thickness 18mm, 3 6mm coats. This is to give you a bit of an understanding in terms of how that system works. You've got a 32mm thick screed on the slab. Your Combiflex that you can see on the left-hand side, which is effectively a jointing solution for both construction and movement joints. That will be installed first at the wall floor junction. You would have adhesive put over the top of that with quartz sand chucked into the adhesive as it's installed to give a key. You would then have your 3-coat render system applied to the walls and down onto the slab, and then your screed would run continuously over the top. So effectively you've encapsulated the space and provided a barrier against any potential water ingress. We have recently launched a very similar system. It's Seeker 1 LC Render. It's a low cement version of our pre-bag system. So LC stands for low cement. So when sustainability is a very important part of a project, which it is nowadays, a lot of projects are looking to be more sustainable. This has 80% less cement, so a drastic saving on the CO2. You're probably looking at roughly, it's hard to give an exact figure, but it's roughly around 74% reduction in CO2 for this particular system. It's sprayable, so when you're looking at application time, one key difference between a cavity drain system and the previous render is the application time. Cavity drain system is very quick and easy to install in comparison to a hand applied render that is troweled on in 3 coats, especially on a project that could be 2,000 square meters. The LC render is spray applied, so you set your pump up on site and away you go. So it's much closer to the application time of a cavity drain system. It's no longer 3 separate products. It's 1 product sprayed in 3 coats. So a lot easier from not only a stock control side of things from internal with Seeker, but from a contractual point of view as well, in terms of making sure they have the quantities on site. We got great customer feedback in terms of the application and how well the system works. And although we have replaced the system, made it more sustainable, it's actually outperforms the previous pre-bag system in a lot of instances in terms of bond with the structure, in terms of the amount of water pressure it can withstand. It's a highly durable 3-coat multi-coat render. It's just the fact that it can be spray applied and is low in cement. So yeah, excellent for the carbon footprint. An overview in terms of how this system works. Again, it's exactly the same as the previous system. Still the same application method. You're just going from 3 separate products applied in 3 coats to 1 product applied in 3 coats that has 80% less cement in it. And that gives you an understanding in terms of what that saving is. So yeah, 950 kilograms of CO2 are emitted for the fabric of every ton of cement. So yeah, almost a ton of CO2 for every ton of cement, which is a massive amount. So the fact that we've been able to reduce the amount of CO2 in this particular project is huge. So why the system was changed? Innovation for sustainability and performance. Obviously, sustainability is a key driver for Sika over the sort of coming years, and we're looking to see what we can do internally to make sure we are as sustainable as possible. A requirement from architects for more sustainable products. Obviously, cement isn't sustainable in any way, shape, or form. It's a massive emitter of CO2 within the manufacture process of cement. So the fact that we've reduced that by 80% is huge. It's a simpler system and simpler to install. There's reduced labour costs, and there's a massive increase in terms of speed. So it's the speed of install is huge compared to previous systems. Other Type A render systems, these are sort of ancillary products that can be used in conjunction with other systems, but they're worth mentioning as they may be suitable for some projects that you do work on. But Sika Lactic 1K is a 3mm cementitious slurry. It's polymer based, so it's slightly flexible, which means it's not as durable as some other multi-coat renders. So you wouldn't leave it as your exposed finish. It could potentially be damaged over time, but is highly durable in terms of the amount of water pressure it can withstand. Very quick and very easy to install. So waterproofing bathroom, showers, terraces, balconies, and swimming pools may be a sort of a key installation area for this particular product. And then damp-proof slurry, again, a thinner slurry coat system compared to the 3-coat multi-coat render of Sika 1, but it's perfect for certain types of application like residential and domestic products. Where I mentioned earlier, you've got that breaking continuity between the basement waterproofing and ground floor waterproofing on a refurb. This can be used above the intermediate slab to provide a 1 meter overlap between basement waterproofing and ground floor waterproofing to make sure that continuity is somewhat maintained. So although we provide cavity drain systems and the 3-coat multi-coat renders, we do have a lot of ancillary products that are used alongside those to make sure that the system is robust as it possibly can be. And these will all be incorporated within any designs that we do provide at that early design stage. As mentioned earlier, removal of existing finishes. This is something that is required for both Type C and Type A systems. What you don't want is the existing finish that's been applied, especially with a cavity drain system, blocking up the cavity drain system. With a Type A barrier system, you want that applied directly onto the substrate, because the substrate is what's going to help that product hold back the water pressure. We don't know what the existing finishes are, how durable they are, so applying it directly onto that will compromise the waterproofing. The waterproofing is only as strong as the substrate you apply it to. So we need to hack off the existing finishes, whether that's through grit blasting, bush hammering and scabbling, exposing that existing surface to then apply whatever membrane we intend to use on that particular basement. So again, something that needs to be factored in at that early design stage, that existing finishes need to be removed. Substrate repair. We want to repair the substrate prior to the application of any system. Again, you want to stop any live and active water prior to the install of Sika 1 or a cavity drain system. You don't really want to work in a completely wet environment. We have repair products for that. Typically, when plugging before using Sika 1 render, we'd use Sika 4A. Effectively, it's a rapid mix to plug that live water leak prior to the application of the render. The render won't be able to be applied to a live leak. Damp walls are fine, but no live leaks, so these will need to be dealt with prior to the application. So plugging that leak is key. We have resin injection systems that can be used if the 4A isn't suitable, and pressure release. Now, maybe a difficult one to explain over a Teams presentation, but I'll do my best to do so. Effectively, they would drill a hole into the wall and insert a pipe into it. You would then render up to where that pipe is. So all the water is coming out of that path of least resistance where the pipe is. So you're managing the water that's then coming through the wall. You'll render up to that point, so the rest of the wall is waterproof, and then you would plug that hole and render over the top of it. So it's a very effective way to deal with live active leaks in basement refurbs. Preparation is typically something that's included within the specialist contractor's contract, whether that's for cavity drain system or the render. It's something they'll include within their package, but it has to be done. There needs to be substrate prep before applying any fully bonded system to make sure the bond between the structure itself and that render is as strong as possible. It also removes any potential debris and any latents that could potentially cause a lack of a bond between the render and the substrate itself. If surface consolidation is required, we also provide solutions that can accommodate that. Existing basements, basement refurbs don't always have the best substrates. You're working with existing conditions. There may be things that need to be done to strengthen the substrate or consolidate it prior to the application of the render. Sika Monotop 4012 can be used to consolidate it. That can be used alongside a mesh or directly onto the substrate itself. Joints, again, a key part. Joints are a huge weak point within waterproofing, whether it's new build or refurb. So making sure they're detailed in the first instance is key. That would typically be with Sikajor Combiflex, the bandage system I showed on that detail earlier on. Movement joints must be waterproof to accommodate the level of movement that is expected. So we would need to have that conversation at an early stage in terms of the type of movement expected, the amount of movement expected. This will give us an indication in terms of the type of system that can be used to accommodate that movement. And this is the sort of level of typical detailing we'll be providing for the projects. So showing the details blown up. Give you an indication in terms of the products that are used for each particular section of that retaining wall and slab. And then those joint areas will have enhanced details that will run alongside it, which will give a bit more of an indication in terms of what that will look like from an application point of view. So Sikajor Combiflex, the jointing system. So easy to install for construction and movement joints. Effectively, it bridges the construction and movement joint. The middle section is effectively left loose to accommodate for any movement, and that will be used at all wall floor junctions and all floor soffit junctions when using a cementitious internal render. So making sure that is there is key, otherwise you potentially risk compromising the waterproofing and causing cracking to the render system that's been applied. Fixings. When working on an existing basement, fixings are always something that pop up in terms of how they can be accommodated. Your waterproofing is internal, so fixings are going to have to be in and around where the waterproofing is, which is why it's always so crucial that the waterproofing is detailed accordingly to make sure these aren't penetrated by any type of fixing. One of the ways in which we can do that is through lightweight fixings. So adhering timber battens directly onto the render and then fixing into those timber battens. That avoids any potential compromises of that waterproof barrier that's been used internally. But they can be detailed from an early design stage. So if you are aware of where the fixings are going to be at the point of design, we can accommodate that within our details, and therefore the contractor, when they're on site, can form these preformed pockets to accept the fixings. That way, the waterproofing continuity is maintained continuously throughout the structure, and you don't have any breaks in that continuity. Now, I am aware that things change on sites, and all fixings can't be detailed at a design stage. There may be things internally that a contractor needs to fix at a late stage of a project. If that is the case, There's no way around it. If the waterproofing's been installed, typically what we would do is create a resin anchored fixing. So a hole would be pre-drilled, it would be filled with Sika anchor fix, and then that would create your resin anchored fixing. Now we want to limit this as much as possible, because by doing that you're compromising and fixing through a waterproof barrier, but there are ways around it, worst case scenario. There's also indirect fixing, so top and bottom fixings, creating a top and bottom sort of unit and then fixing directly into that, whether that's a stud wall or partition. Repairability of the render, as mentioned with the cavity drain system earlier on today, it's a repairable, maintainable system. It's relatively easy to repair and maintain that through the access points. Not necessarily the case with the render, as it's a fully bonded system, but what would happen is sections of the render can be cut out, and then you rebuild it with 100mm laps. So similar to day joints, you're not creating one straight construction joint through the render. There's a gradual overlap in the system so there's less of a weak point there, but effectively it can be repaired if areas have failed due to cracking, debonding. Sections can be cut out and infilled. And then case studies. Typically, we have a wide range of case studies on the website anyway for you to look at, and we are actually launching a new case study very shortly for the LC render, the spray application, a project in Finsbury Dials in London where it was applied over 2,000 square meters. So we have a wide range of projects you can go back and observe where these systems have been used and how well they've been used. I would check with a structural engineer with regards to enabling works. Check the slab can withstand the pressure. These are just things, key points to take away from today, actually, and things to bear in mind when looking at what system can be used and what system can't be used. But when it comes to the render specifically, I'd always check the slab can withstand the new loadings of the Sika 1 render. Existing waterproofing may not be compromised. Confirm the integrity of the existing waterproofing. Enabling works for cavity drain system 2 for listed structures. Make sure all these points are sort of considered at an early stage to make sure you're designing the system accordingly and making sure the system you're proposing is the best system for that particular scheme. And then in conclusion, key takeaways from BS8 102, the 4 different grades of basement. So grade 1A, wet and seepage tolerable. Grade 1B, damp from groundwater. Grade 2, damp and damp patches from condensation is tolerable. And then grade 3 is your completely dry internal environment. So from an early stage, understand the client's expectations and what they're hoping to expect out of their space. If they are happy with damp patches from condensation, then a grade 2 may be tolerable. But if they are after no water ingress whatsoever, then it would need to be grade 3. So always be aware of the grades of basement for each individual area within that basement. And then the protection types, 3 different types of waterproofing systems, whether it's a type A barrier protection being used, type B structurally integral, and type C, or a combination of multiple of those systems. Again, Sika as a business provide all of those solutions, so we can help with any form of waterproofing that is required for that particular scheme. Key takeaways, speak to us. We're happy to be incorporated in that design team at the earliest possible design phase. We have a large team full of experienced individuals. We're experienced in working on some of the biggest projects in the UK. We've been waterproofing since 1910, so an incredibly long time. Although waterproofing has moved on and developed since then, we've moved on and developed with it. So we're always enhancing, incorporating new products within our range. And our range of products are extensive. As mentioned, we provide all forms of waterproofing, types A, B, and C. We have a large team of on-site technicians. So we're present on site. We don't just provide products and allow the contractor and everyone else involved in the scheme to get on with it. We do have a site presence to make sure those products are being installed in accordance with our recommendations. Whether we're doing that or one of our specialist contractors are doing that, we're heavily involved and make sure that the system we're providing is robust, both from a design point of view and an application point of view. We can also provide roofing, flooring, ceiling bonding and repair solutions. So don't just think of us as a waterproofing company. There are other solutions within your basement we can provide information and products for. Reduce your risk, guarantees and backup. So yeah, make sure that the product that's being provided is supported by a guarantee, whether that's a product guarantee or an installation guarantee. All of our products have product guarantees, and the specialist contractors that we work with provide installation guarantees. So making sure that that's tied up from an early stage is also key. But yeah, as mentioned, a team full of CSSW qualified experts providing specification and design support. That covers it for the presentation. As mentioned, we will have a bit of a Q&A. So if you do have any questions, please feel free to ask them in the chat. If you've asked them in the chat already, we will get round to answering those. But yeah, thank you very much for your time.